everyone, this is Sukruti Joshi from LG Institute of Engineering and Technology, Ahmedabad. I am going to take the video lecture series on chemistry. The subject code for chemistry is 3110001. Now, in our previous session, we have started our chapter number 1, which is general chemistry, right? In this particular subject, we have to look into different kinds of general chemistry's principle. Then we have to look into certain kinds of nanochemistry principles, green chemistry principles, etc. So here we have seen the structure of an atom. Afterwards we have seen what is a bond. Then we have seen which are the types of bonds, in which we have studied ionic bond as well as covalent bond, right? After that, we are going to start the next one, which is metallic bond. Metallic bond is basically a bond which is formed between a metal and a non-metal. That means a metal atom and a non-metal atom combines together or attracts with each other through a bond which is known as metallic bond. Okay? Now, let's say for an example, we have FeCl2, FeCl3, K2CrO4, K4Cr2O7 or KMnO4, right? These are the basic, or I should say, the best examples of metallic bonds. That means it contains two different kinds of atoms, a metal and a non-metal. Both of them came together and forms a very unique compound. Now, here we can take another examples also, right? Next one is hydrogen bond. Hydrogen bond is a very widely available bond. We all know that because it is present everywhere. How it can be present everywhere? So we all know that water is present everywhere in different forms. It can be a solid one, it can be a liquid one, it can be in a vapor phase, right? So along with it, here it is possible that such kind of bond is present in each and every kind of particular compound which contains H. Okay, so the electrostatic attraction between a hydrogen atom bonded to a highly electronegative atom, such as any highly electronegative atom, we can take an example of halogen here, right? So such kind of bond formation is known as hydrogen bond. Okay, let's take the examples of it and let's see the types of hydrogen bonds here. Okay, so if we deal with this, how many types of hydrogen bondings are there? So two main types of hydrogen bondings are there. Number one, intermolecular hydrogen bond, and number two, intramolecular hydrogen bond. Okay, now here what is the meaning of inter and what is the meaning of intra? So intermolecular hydrogen bond is a type of a bond which is formed between two different molecules of the same or different substance. It is formed between two different molecules. Okay. Now another one is intramolecular. So intramolecular hydrogen bond is basically formed between a hydrogen atom and a highly electronegative atom present within the same molecule. Okay, there a molecule is different. Here the molecule is same. Here in the image, as you can observe, what we have is an example of HF, example of H2O and NH3. Here as you can see, a hydrogen atom is bonded with a highly electronegative atom. Okay, so if you can see H and F, when a bond formation occurs between one HF molecule and another HF molecule. So at that time, that is referred as intermolecular. But the bond formation occurs within the same molecule, within H and within F, or between these two in the same molecule. Then it is referred as intramolecular hydrogen bond. Okay. Similar way you can observe it in H2O. Similar way you can observe it in NH3 also. Okay. Now, let's move on to the next topic of this particular chapter. That is KOSSEL-LEWIS approach to chemical bonding and Lewis dot representation. Two scientists are there. Their name is KOSSEL and Lewis. In 1916, they gave successful explanation based upon the concept of electronic configuration of noble gases. Right? So what are these noble gases actually? Here, now we all know that noble gases means inert gases. Inert gases means their outermost shell is fulfilled or totally full with the electron. Okay? Here, the atoms of the noble gases have little or no tendency to combine even with the same one, same atoms also. Right? They are so inert that they did not form even a diatomic molecules. This is their tendency because there is no space for an electron to came out, or there is no space to came in, and because of it they are known as stable noble gases, or they have stable noble configuration. Right? They are very stable at higher temperatures also. Here I have given you certain examples. First one is helium. If you can see here, its electronic configuration is 1s2. One orbital can maximum occupy 2 electrons. So here they are 2 electrons. So the orbital is full. No chance for entering the electron from outside. Similar way, if you can observe it here, we have neon, right? It's 1s2, 2s2, 2p6. Again, the last orbital is 2p orbital and it is full to its maximum capacity. Likewise, we have here argon. As you can see, the last one is 3p6. Again, it is totally fulfilled. So there is no chance that any other atom can combine with it, right? Based upon this, we got an octet rule here, right? Or it can also be known as rule of octet. What is the meaning of rule of octet? So, all atoms other than noble gases have less than 8 electrons in their outermost shells. Right? Therefore, they combine with other atoms in order to achieve noble gas configuration. So in simple manner, each and every atom combines together to form a stable noble gas configuration. After that only they become stable. Right? So the principle of attaining maximum of 8 electrons in the valence shell of an atom is known as octet rule. Now, our next topic, which is Lewis representation. Lewis representation is basically a dot structure representation. So, a scientist named Lewis introduced simple symbols to denote the electrons present in the outer orbital of an atom. And these electrons are known as valence electrons, right? The symbols are known as electron dot symbols, and the structure of the compound is known as Lewis dot structure. Here in the image I have shown you a dot structure of methane, right? As you can see, it contains a covalent bond, so CH4. Each and every hydrogen bond, here as you can see, hydrogen is combined with carbon by sharing of its electron, one electron, right? Now, our next topic, a very important topic for a bond to form, which is coordination numbers, geometries or shapes of the molecules. They plays a very important role because only and only this coordination number shows the direct effect on the shapes of the molecules, right? Here, the total number of points of attachment of the central element is termed the coordination number, and this can vary from 2 to 16. Generally, it is 6. In simple terms, coordination number of a complex can be influenced by the relative sizes of the metal ion, by their electronic factors, by their electronic charge. Okay, these are the general terms which actually shows the effect on coordination number, and the coordination number shows the effect on shapes, right? Let's move on to the different shapes of the molecules as well as their geometries, as well as their examples. Okay, here first shape is a linear shape. As you can see in the image, we can take an example of CO2, right? CO2 has a linear shape. Similar way we have HCl, HBr and HF, right? This is a very common 2 atom contained or maximum a totally covalent compound shows such kind of linear bonding. Okay. Next is oxidation states. When we talk about any kind of oxidation state, at that time we have to understood that the oxidation states plays a very important role. It indicates the number of electrons that an atom uses or receives when it forms a compound. How many electrons it can accept and how many electrons it can donate, both the things can be decided based upon the oxidation states, right? For an example, group 1 has generally the valency of 1, as well as they have the oxidation number of +1. Likewise, we have group 13 which has generally the oxidation number +3. Okay. Let's move on to the next one, effective nuclear charge. So here we have to see what is an electron shielding. Generally, if an electron is far from the nucleus, then at any given moment many of the other electrons will be between that electron and nucleus, and this electron cancel the portion of positive charge of the nucleus, and thereby they decrease the attractive interaction between it and the electron further away. This is basically known as electron shielding, right? And because of it, this kind of effect is observed. Next is polarizability. Polarizability is the basically electron's ability cloud to move or distort other electrons, right? Generally, from left to right it decreases and from top to bottom it increases. Next we will see in our next session